and that is going to be quite advanced.
Yes. Basically, we would be talking about NumPy and Pandas libraries, which would be used for your data science and machine learning applications. So thank you so much, everyone, for joining back again. Those who I have already sent a mail to most of you regarding the slides and the code. I would be sharing it with Kusum ma'am also, and she would be sharing it back with you as well. So continuing with the discussion that we were having in the previous session about Python, that we talked about the list, tuples, dictionaries, and sets, the different data structures available. And we also talked about the conditional statements and loops and the input and output. Today, in this particular session, we'll be talking about the two main libraries of Python, namely NumPy and Pandas, which are used extensively for data science and machine learning applications. And they are very, very much useful for data science. And they actually make your tasks very easy to do. They have a lot of operations with these which these libraries, which you can very easily perform. So let's start with that. Just give me a second. Okay. So we say collab. So just to speedify the things, I have the functions already. I have the statements already written, so it will be a little faster for you. I'll give you time to write them for yourselves also. So then first and the foremost is import statement. Import NumPy as NP. The first and the foremost statement is import NumPy as NP. This is the Jupyter IDE that I was talking about. Import NumPy as NP. If you execute this, then this particular library NumPy would be available for you for your functions, and it is given an alias as NP. So at any point of time, if you want to use any of the functions of the NumPy library, you don't have to write the complete NumPy word. You can simply say NP. You can simply say NP. So NP dot whatever functions that you want to use. You don't have to write complete NumPy dot. Okay. The alias is basically given just to make the things a little more easy. Now, there are certain facilities which are given to a NumPy array. You can create a normal array and a NumPy array. So what is the difference between a NumPy array and a normal array is, because a normal array would be just having the subscripts and you won't be able to perform operations onto it. But in the case of a NumPy array, NumPy has lots of functions which we can directly apply on that array. So we basically convert a list to a NumPy array. We convert a list to a NumPy array. So what is this? This is a list, which is converted to a NumPy array, like this. Now, if I say what is the type of X, it will say it is a NumPy n-dimensional array, NumPy nd array. Try doing it. Try doing this NumPy n-dimensional array and try printing the type of X. We can also use a function like suppose I already have a list. I already have a list. Then I can also convert it to a np dot as array. And I give the value as L. So this will also be a NumPy n-dimensional array. Python is a case-sensitive language, so small x is different from capital X. So if you have an existing list, that can also be converted into a NumPy array. We didn't do slicing at the time when we were doing lists, but here we would do slicing. So what exactly is slicing? Suppose I have an array. I have an array like this. Let me take a look. This is my array. And I have my values stored in that array. Suppose the values stored are 20, 19, 3, 4, 5. Or let me take an array. Let me take a list and then I'll do a copy paste. That would be a better option of doing it. This is my list. This is my list. And let me have a print screen of this. This is my list. And it is stored in the form of an array. It is stored in the form of an array. Like this. Okay. And the values which are, it is subscriptable, which we have already discussed. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And similarly, there is a negative subscript also. So 90 can be referred to -1, 64 to -2, -3, -4, -5, 6, 7, 8, 9, 10, 11, 12, 12, and -30. All are minus. All blues are minus. -9, -8, -7, -6. So there are two ways to access an element of a list. Either it can be from left to right. If it is from left to right, it is positive. Positive. And if we go from this direction to this direction, we go for a negative subscript. So if suppose I have to access 89, suppose I have to access 89. So this 89 can be accessed using L of 6 and also L of -7. if I say L of -7, then also 89 would be accessed. Got it? This 89. So it can be in the positive direction, it can be from left to right, or it can be from right to left. In both the ways, we can access it. The second thing that I want to show you is, if suppose I want to access these three elements, 89, 96, and 54. These three elements I want to access. So I would say I want to go for 6th, 7th, and 8th element. So it can be represented like 6 to 9. Why? Because 9 is always excluded. The second subscript is always excluded. So if I say L of 6 to 9, 89, 96, and 54 would be accessed. L of 6 to 9, 89, 96, and 54 are accessed. These three elements. And if I want to go for a negative subscript, so negative subscript will go from -7 to -5. It is negative, it goes in the opposite direction, but when you are giving it for the slicing, it will be in the same direction, -7 to -5, because -7 is smaller than -5. We are saying 6 to 9. 6 is smaller than 9. Similarly, -7 to -4 basically. So L of -7 to -4. Got it? This is known as slicing. Slicing. When I want to access more than one element, I can go ahead with the help of a colon sign. Similarly, if I want to access 34, it can be L of 0 or L of -13. So 0, 1, 2 can be done with the help of 0, 2, 0, 1, 2, 0, 2, 3. Or it can be -13 to -11, -10 basically. -13 to -10. Same. So there are two ways to access the elements of the list, either a positive subscript or a negative subscript. Okay? Either a positive subscript or a negative subscript. And I can go for the slicing to access more than one element. Shyam, sir, there is a way of printing the index in which you want to find out the index. Index is actually the function name for lists. So L dot index, and you would get to know the index of an element. So I'll simply say L dot index of 34. Yeah, 76. So it says it is at the first position. No, 0, 1. So it is at the first position. So index gives you the index of an element. Okay, so slicing is clear. Is slicing clear to everyone? We can go for negative and positive. Then there is one more thing. If I am writing 0, if I want to start from the very beginning, I can simply say nothing and 3. So by default, it will give me from 0. And similarly, for the last members, I can simply say -10, and I don't give anything after that. So it will take all the members after -10. All the members after -10. Okay, so if I don't give any value at the last, then it will take it till the last. If I don't give any value at the first, it will take all the elements till the first, till that element. It will take all the elements starting from the first till the subscript. It will take all the elements from the first till the subscript. Is this clear to everyone? Is slicing clear to everyone? So can you give me the answer for the last three elements? I want the last three elements. Can you give me the answer for the last three elements in positive and negative both? With colon. Last three elements with colon. -3, yes. And in positive? -3, 2. So it will give the last three elements. And if I go for 10 colon, it last three elements. If I write 10 colon 12, then 12 will not be there. So it will have only two elements. Because 12 is excluded. Got it? Yes. Okay. So moving on to the NumPy part. We were able to convert a list to an array. We can also convert a integer list to float and then to a NumPy array. So that is also possible. Suppose I have this list and I say I want to convert it to a NumPy array is equal to np dot as array L comma float. So all the values would be converted to float. See, all the values have been converted to float and then it is converted to a NumPy array. Then the next very important function which is used is shape. So n dot shape will give me, sorry, we don't give the brackets here. So n dot shape will give it has 13 elements and it is a single dimensional array. I can create a double dimensional array also in Python using NumPy. So I can create something as this as a double dimensional array. Let me make it as x1. So what you will do is you will give the first row and then you give the second row. First row in square brackets, comma, second row in another brackets. So if I print x1, it will be printed like this. I'm copy pasting the code so that you can try it out. It's a NumPy array, double dimensional NumPy array. Like suppose if I say I want to have a I want to have 3 rows and 3 columns. So what I'll do is I'll say np dot array and I'll give the values. What are the values? I'll say 23, 46, 24, comma, 64, 35, 88, comma, the next row, and I add one more row to it. Like this. Oh, sorry, as array. NP.array is fine. I think the brackets are missing. Yes. There would be one bracket here and one bracket here. Then it will work. Yes. So if I say x2, and I can also go ahead and find out the shape of this. So it will say it is a 4 cross 3 matrix, where 4 is the number of rows and 3 is the number of columns. 4 cross 3 matrix. Okay. Now the same rule of slicing will work. In this case, I will have to give two parameters. The first parameter will be for the row number, and the second parameter will be for the column number. Row number and the column number. Okay. So suppose if I want to have 46. So it is on the 0th row and first column. So 0th row, first column, 46. And if I want to have 46 and 24 both, 46 and 24 both, so it would be 0th row, and I have to give two columns. So 1 is to 3, or I can remove 3. 46 and 24 are given. Can anybody tell me the command for 46 and 353? 46 and 353. Sorry, 47 and 353. 47 and 353. Forty-seven and 353. Mind you, you have 2 rows and 1 column. Two rows and 1 column. Two, 1 and 3, 1. So how will you find out 2, 1 and 3, 1? So you'll simply say x2, 2, 1 and 3, 1 you already know. So 2 is 2. You don't have to give the third last one. 0, 1, 2 is 2. You don't have to give the last one, comma 1. 47 and 353. Okay, the trickiest one. I want 35, 88, 47, 99. 35, 88, 47, 99. So I think I can annotate here. Yeah, I want these 4. No, Monali. You will not get the answer in this. Try it out first before writing. Yes, Arun Kumar sir. This is correct. So x2, 1 is to 3, 1 is to 3. Perfect. 35, 88, 47, 49. Got it? Slicing is clear. See, I want, what does it say? 1:3 says, starting from the second row. Okay, let me annotate. 1:3 says this is 0, 1, 2, and 3. 0, 1, and 2. So if I want this is basically 1, 1. This is what? 1, 2. 2, 1, 2, 2. So what are the rows? First and the second row. So 1 is to 3. What are the columns? The first and the second column. Comma, first 1 is to 3. I may have also not written 3 here because 3 is the last column. I can do it without writing it also. Got it now, Deepti ma'am? So I could have done it by omitting this also. This will also give me the correct answer. Okay? Slicing is clear to everyone. Next, we move on to some other functions of NumPy. Other functions of NumPy says, I can create a NumPy array of all zeros and an identity matrix also. So I can create a NumPy array of all zeros, np.zeros. And what is the dimension that I want? 3 is to 3. That's a double call, double brackets. So if I print x3, it will give me a zeros NumPy array with 3 cross 3 dimensions. Similarly, I can go for np dot an identity matrix for 3 cross 5. Array x4 like this. So this is an identity matrix. Generally, we go for a square matrix in the case of identity matrix like this. Identity matrix, zeros matrix. And I can also create a random matrix. Now this is important because many a times you need this. X5 is equal to np dot random 3, 4 like this. So it will create a random matrix. Random np dot random because random is a library and another random is the function. So this is the name of the library inside the NumPy, and this is the name of the function. And I can print that. Now this actually by default takes the values from 0 to 1. So I'll create a NumPy. Now x5 is a NumPy array. If I try to print it, what is the type of x5? It will say it is an n-dimensional array because I have used the function of NumPy. Now np.random.random 3, 4. So it will create a random array of 3 rows and 4 columns. My question to you is, I want a NumPy array of 4 cross 4 and the values are between 10 and 20. I want a random array. I want a random array of 3 cross 3 and the values are between 10 and 20. 10, 11, 19, 14, 16, 18, 3 cross 3. 10 and 20. So 20, 11, yeah, 12 kar do usko, aur ye 30. Aise. I want this as the answer. Find it out. You have to use some other function. Google it. A hint is to Google it. Anyone with the answer? What will be the function name? Trang, Jain? What will be the name of the function? Yes, Lavkush, sir. That's absolutely correct. Random.rand int. When I'm using random.random, then it is doing it from 0 to 1. But if I'm going from random.rand int, then I can give the values. So what will be the exact function? Give me the exact function. Give me the exact function. No, sir, rand int is the name of the function. Yes, Swapna ma'am. Absolutely correct. So I can go ahead and print X5. It will give you a 3 cross 3 matrix between 10 and 20. Got it, everyone? Then I can find out the transpose of a matrix by simply saying dot T. So if I say X6 is equal to X5 dot T, print X6, it will be the transpose of the matrix. So 19, 16, 10, 14, 19, 11, transpose of this matrix. So I can very well find out the transpose of this matrix. Then a very important function which is used in most of the DS applications, data science applications, is summation. So I can very well find out the summation x6 dot sum. This will sum all the elements. 19 plus 16 plus 10 plus 14 plus 19 plus 11 and so on. And if I want it axis wise. Now, what is the meaning of axis wise? Suppose I want the summation of this row, or I want a summation of this column. I can do that. So if I say axis is equal to 0, so it will say 45. 45 is basically 45, 53, 38. So it is giving, when axis is equal to 0 means it is doing it row wise. Axis is equal to 0 means row wise. So 19 plus 16 plus 10, 14 plus 19 plus 11. Sorry, column wise. When axis is equal to 0, it is doing column wise. 19 plus 14 plus 12. Let me annotate. So it's 19 plus 14 plus 12, which is 45. 16 plus 19 plus 18, 53. 10 plus 7 plus 11, 38. Axis is equal to 0. And if I say axis dot sum and axis is equal to 1, this will do it row wise. So actually both were 45 na, so isliye wo confusion hua tha. So 19 plus 16 plus 10, 14 plus 19 plus 11, that is row wise. So this is very much required in data science applications if you want to have the addition of all the numbers. So I can very well do it like this. I'll say R is equal to, and then I can find out the average of it. So average is equal to R divided by 3. Print AB. I can find out the average also. Yes, so this is the average of all the rows. Axis is equal to 1 was row wise. Average of all the rows. And if the total sum was, we calculated the total sum, SS is equal to x6 dot sum, correct? And we can find out the average of the total thing also. SS divided by 9. Because there are 9 elements. So what is print AVR? Is the average of all the elements. 15.1111, average of all the elements. Yeah, we'll talk about reshape, Arun Kumar sir. Is this clear? Some part is clear. Row wise, column wise, and accordingly we can calculate the average. Actually, there is a function of average also, which can be done axis wise. Direct. Yes? And there is another function which is known as reshape. Now, in this case, this is all 3 cross 3 matrix. Suppose if I have taken a 4 cross, let's go for this only. I'll create a starting from 50 to 80, and I create a 4 cross 3 matrix. This is a 4 cross 3 matrix, 4 rows and 3 columns. I want the other way around. I want 3 rows and 4 columns. So I can very well say x7 dot reshape 3, 4. The numbers will remain the same, 72, 57, 63, 69. It will take the numbers row wise, like this, row wise. But if you try to do it in a different number of, like suppose if I say reshape 25, 5, 5. Now this will require 25 elements. I have only 12 elements. 3 4s are 12, 5 5s are 25. It will give you an error. So as you had it earlier. So it can be 3 cross 4, or it can be 12 cross 1, or 1 cross 12, and so on. You cannot remove the elements, neither you can add the elements. Neither you can remove the elements, nor you can add the elements. Keep it in mind. Please try these two, rand int, reshape, and sum. Please try these 3 out. And then we will move on to pandas. Yes, pandas. I'll give you 2 minutes of time to try it out. Sham sir, you done all the three? Random int, sum, and reshape. I want others also to say yes if they have done that, so that I can proceed further with pandas. 59, yes. This is an error because I had only 12 elements and I'm trying to reshape into 5 cross 5, which will require 25 elements. It's not possible. That's what it says. Cannot reshape array of size 12 into shape 5 cross 5. So I can only reshape it to, I can do it x1 dot reshape 12 cross 1. This is allowed. I have 12 columns. Or I can go for x7 dot reshape 1 comma 12. So it will have 12 rows, 12 columns like this. This is all allowed. No, padding is not possible. That's what I said. Padding is not possible. That is why you will get an error. Okay. Yes, Deepti, you can try that out. Modify the numpy array and then you do the reshape. That is allowed. Okay, so if everyone has done this, we can go to pandas now. Let me check if any numpy function is remaining. Arrange is fine. We can find out the inner product, the outer product, and these are some of the functions which are used in numpy. So that all can be skipped, and let's go for pandas. So for pandas, Kaggle is a website which contains a lot of data sets. And generally, most of the data scientists and machine learning experts are now using Kaggle for their research purposes because it has a lot of data sets with it. So just go to Kaggle, give your credentials, and go to data sets. This looks good. Detailed shopping by product. And I can go ahead and download this data set. Okay? I'll download this data set. I'm sharing the link with you all. Once you have downloaded, please let me know and I'll proceed further. Try doing it. Once you have downloaded the data set, let me know. How to import more than one file from a folder? You can do that. Trang, you are moving a little ahead. We are still need to study how to import. So please hold on. Have you all downloaded this file? So if you check the format of this file, this is downloads. If I check, it has one file, XLX file. Now just copy this into one designated folder. Like I have a folder inside D drive as datasets. And there I store all my datasets. And this is the name of the file. So let's put it shopping, the name of the file as shopping. So if you just double click this shopping file, it will give you the data, complete data. So it has these many rows and it has a different type of data sets. Now all the cleaning of the data set, removal of the null values, all these would be done in exploratory data analysis, which you would be doing the later part of your workshop. But as of now, I'll just show you that how you can upload a file to your Jupyter or to Colab. We'll discuss both Colab and Jupyter, and how you can access the different rows and columns. We'll talk about till there. So this is my data set, and I want to use it in my program. I want to use it in my program. So I'll say import pandas as PD. So I have imported now pandas as PD. The PD is again the alias which is given to pandas library. Whenever I want to use the functions of pandas, I'll say PD dot and so on. Dipti, I have just downloaded the file till now. I have downloaded the file and copy pasted into some location. And what is that location? D drive में data sets के अंदर I have pasted it. That's it. Do it till here. You may or may not rename it. I renamed it for my own purposes so that I can remember the name of the file, because the name of the file was something different, Compras and so on. So I just renamed it to shopping for my own benefit. That's wonderful, Prasad sir. You already knew how to export that? Yes, Compras. Now the next step is I want to upload this file to this Jupyter notebook. Okay, sir. So what I'll do is I'll say data frame df is equal to pd.read underscore csv. It's an XLX file. So first of all, you have to convert it to a CSV file to be used. So I had shopping.xlx. How do you do that? If you just go on view, it will have an option of showing the extension also. So just you show the extension and convert it to a CSV file. That's it. Or you just open it and save it as shopping.csv. That is also allowed. Like suppose if I go here, and I'll say file, save as, browse. And I'd give the CSV from here. CSV. MS-DOS. So here also I can go ahead and give the name of the file. So either you go it in this way or you just modify the name of the extension from here, shopping.csv. Then you want to know the link, the complete address of this. So you just go on the top and say copy address as text. You go on the top and say copy address as text. Do it. Convert it to a CSV file. And then you on the top say copy address as text. df is equal to pd.read_csv. Give the link and the name of the file, shopping.csv. It will give you this error. It will give you this error. Anybody got this error? You can remove this error by simply saying R here. By simply saying R here. Some problem with the data set, I think. Let me save it. Downloads. I'll save it instead of changing the extension. Instead of changing the extension, I'll save it as shop.csv. Some problem with the UTF codec. Actually, the data set is not very good enough. Let me try it out on Colab. In the case of the Colab, you click on here, files. And then when you get this, you upload that. That's the only thing that you have done, you have to do. It will take some time. Yes, Abhilasha, I'm also getting the same error. It's a problem with the data set. Actually, I took a random data set. Okay. If the problem pertains, then we'll have to go for another data set. Yes, it's the same UTF-8 codec can't decode. We'll have to take some another data set. Let's go to Kaggle again and pick some other data set. This is the IPL auction data set. Same process you have to follow. Same process you have to follow. Go to downloads. archive 11, copy datasets, paste it, and you copy this. This is the name of the file. It ran successfully. So that was a problem with the dataset. Link of the new dataset. Okay. Same process. Download it, copy it to a folder. You may or may not rename it, just like I have not renamed it. I have kept it as it is. Because now you would be using only DF. You don't need this now. Similarly on Collab, I'll upload this file now. IPL. And instead of shop, I'll simply say the name of the file. It executed well. Got it? Everyone got it? I'll wait for 3 minutes here. Yes, we can do it in PyCharm also in the similar manner. So we are reading the file in the similar in this way. We are reading the CSV file, and the head will give you the first 5 rows of the data set. This is we are exactly reading the file. So read.csv basically imports the file and keeps it with the Jupyter or Colab or whatsoever, whichever platform you are using. And df.head will read the first 5 rows of your data set. R Swapna ma'am is used in which cases, and sometimes you have the problems with the reading of the file. So you would use a R there. It doesn't, sometimes it solves a UTF coding part and sometimes it doesn't. So in the previous example, we saw that it didn't solve the problem, but generally it solves the problem of UTF encoding. So let me know if all of you are here, you are able to read the file df.head and you are getting this answer. I want a yes from all of you, and if you are through, then only I'll proceed further. Abhilasha ma'am, Arun Kumar sir, Swapna ma'am, Shyam sir, Amrita ma'am, Swami, Pinky, Chetna ma'am. I want all others to give me the answer. If yes, then I'll proceed further. Okay, so if everybody has done that, then we can go ahead and say df.head. It will give you the first 5 rows. df.tail actually gives you the last 5 rows. Last 5 rows. And on Colab also, you can do in a similar manner. df.head will give you the first 5 rows. If you want to find out what is the type of the df, you just type df and it says it is a pandas data frame. Similarly, you can find out the tail, the last 5 rows. Then there is another function which takes care of any one of the rows. So df.loc, and then you can give the name of the row, number of the row. So it gives you the 10th row. Or I can go for 100th row like this. I can go for the 100th row. So it gives me the details of the 100th row. Okay. Now the next thing that is required is, suppose this is the complete data set and I don't want the type. I just want the players list, the base price, and that's it. I just want only these 2 elements. So what I can do is I can simply say df1 is equal to df. And what are the columns that I want? And what are the columns that I want? So I can give the number of columns, the names of the columns or the names of the other rows. So I want only the players list, the players list. And then I want the base price. Actually, you need to rename this. This needs to be renamed because there are two apostrophe S's. So it is finishing it off here only. It is not going for the rest. So you need to rename the column. Yes. You need to rename the column. You need to rename the column so that I can use the players list. Okay. I want to rename it to the list, basically. I can say it as list. So I just rename it df dot rename columns is equal to, and I'll give the name as players list. And I can say in place is equal to true. I think again it will give you an error because the name is players list and it is not taking the apostrophe S. Yes. So now if I go ahead and say df dot head, so the names of the columns are changed. So player in place is equal to true. This is not an index. That's what it says. Because I have already changed the name of it to player. I've already changed the name of it to be player. Okay. Players list, base price. Okay. It should actually have changed. Again, it is not giving. I'm not sure what is the problem. It is not taking the player also. Let me start from the very beginning. Still not changed. Yeah, that's what I did, Namrata. I'm not sure what is happening with my part. I tried doing this also. I didn't get you, Prasad sir. What are you trying to say? From the participants list for yesterday, we can get attendance and name versus say time. Logging can be print. I don't know. Okay. So the next thing that we can do is we can L in capital list. Okay. Oh my God. Okay. So I had stopped thinking about it now. Yes. So now I could get L was capital. But I was copying and pasting that only. अच्छा तभी ये यहाँ पे भी नहीं हुआ. Oh, अब हो गया. L was capital here. So यहाँ पे भी हो गया. अब now I will have to write player. Yes. So I have renamed it to player. So that is why now it is player. And here it is player. So DF1 L capital nahi tha. So that is why it was creating a lot of problems. And in this way, I can find out, I can take only 2 columns. Similarly, I can take only some rows also. Like suppose if I say DF2 is equal to DF1. In DF1, I have only 2 columns. In DF1, I have only 2 columns. For this, I want only some of the rows. I want only some of the rows. This is nothing but the slicing part which we did. So if I say DF2, here's DF2. So this will have only rows from 20 to 50. 20 to 50. Now this requires a lot of pre-processing. If you see the base price, it is retained also and it is 2 lakhs also. So now I will have to find out the value for retained here because it is a mix of integer and strings. So a lot of pre-processing needs to be done for this type of a data set. This is nothing but slicing that we did. I want only some of the rows and some of the columns. So what exactly I have done is I have taken only that part of the data set which I actually needed it. I needed only 2 columns and I needed only 30 rows. So I have done that. So basically what I have done is, if you open this data set, basically what I have done this, I have removed all these rows. I have removed these columns and I have taken only from 20 to 50. Delete. And from only 20 to 50 is also excluded. This much. Last one. So now this is my data frame. I am working only on this. I can perform so many functions on this related to what I actually need. Correct? So now I can perform operations like I want those rows for which a value is equal to 1. Like I want only those rows for which I want the details for MS Dhoni. So I can say DF2 player is equal to MS Dhoni. So let's take it out that df, I'll say Dhoni is equal to df2 df2 player is equal to, now it has to be completely written as it is there, MS Dhoni. And I can go ahead and print this now. So this gives me the details of MS Dhoni. If there would have been more rows with MS Dhoni, I would have got all those rows of MS Dhoni. Got it? So in this way, I can read a file and then I can perform the various operations on the file. Matrix manipulations, yes. Thank you so much, Mevizi sir, for helping me out in L as capital in list. We can take any such Excel file which is not so cumbersome. Like I just took your data now. I just took your data. Let me take that file now. I have not downloaded it. If suppose I have formed a very simple Excel file. I have a very simple Excel file. I need to go to. Okay, as we said. Actually, that is a problem with Zoom. When you try to open a new tab, this comes in between. Yes. So I'll go for Gmail and I'll download the contact details which I just asked from you. So this was the responses. These were the responses which I had it in the morning. So I'll simply download that. Open it. Enable editing. Okay. And I'll save it as same folder, D, datasets. I'll say IIIT and as a CSV file. Yes. Okay. So now I can open this file also now. I'll say ddf is equal to pd.read. Somebody was asking, can we have multiple files together? So yes, this is the way how we do it. pd.read underscore CSV. I'll go to d.datasets and copy the address as text here. And this is the address as text. And the name of the file was IIITDM. IIITDM. Let me check what was the name of the file. Datasets. Yeah, IIITDM dot CSV. And ddf dot head. See? Now I can make any modification. Suppose if I want only those people who have highest qualification as PhD. I want only those who have the highest qualification as PhD. DDF, PhD. I want it from DDF, DF, DF, highest qualification. The name of the column cannot be different. That's what you have also experienced. I was just writing small s and I was not getting the answer. Highest qualification as PhD. DDF, PhD. See, these are the people who have the highest qualification as PhD. Now I can very well go ahead and find out the shape of this. So I'll get to know, okay, how many people are with PhD. So there were 16 people with PhD. But if you see, somebody has written capital P, somebody has written small p. So I can just convert the cases of all into a, no, a small case. And then also I could have done that. So in this way, I have got 16 people who are who are PhD. And from that also, I can go ahead and find out, okay, all those who are CSE, who are from CSE background, or who are from from mechanical background, etc., etc. So I can do lots of things if I have the with the help of pandas. Yes, Ruchi ma'am, that's what I was saying. So now we can convert all the PhDs, capital P, small p, capital D. Somebody may have not written capital D, so you can do that also. So you convert the cases into small case for everyone, and then you can do the accessing. So this all is a part of EDA, exploratory data analysis. How you are trying to analyze the data set or explore the data set. ILOC is to find out a particular row. Suppose I want to find out the second row. So that is ILOC is used for. This dot ILOC, the 10th row. So this gives me the 10th row, the details about Madhavi Devi sir. Ma'am. Madhavi Devi ma'am. Got it? So such types of things can be done. And you can find out, okay, I want to find out the branch. As I said, I can go for branch, I can go for organization, highest qualification, anything can be done like this. Okay. ILOC and LOC both are used for slicing, as what we have discussed. So LOC is label-based data selection method, and ILOC is an indexed-based selection method. So in ILOC, you give the indexed, and in LOC, you give the element, the range, the slicing method. Label-based. Okay. So since, yes, I told in the very beginning also, the time is quite less to talk about a complete Python and along with NumPy and pandas. But I tried my best to give you a glimpses of everything, and to a greater extent, we were able to do pandas also. That is accessing a file, then reading the file, and doing some manipulations on the file. But as and when you will do exploratory data analysis, a part of data science and machine learning, you'll get to know more functions that you can perform for cleaning of the data, for understanding the data, and so on. Okay. So I'm sharing my email ID. In fact, you all have received a mail from me. So you already have my email ID. This is my email ID. So if you have any questions or doubts or any discussions that you would like to do, please write a mail to me. I would